All right, so let's go through a practice assessment for lines and functions. Um, and the first question is a fill in the blank. In the equation y is equal to mx plus b, m denotes the slope. Okay, so m denotes the slope of it, and b denotes the y-intercept. And to be technical, it's the y-coordinate of it. So b denotes the y-intercept where it crosses through the y-axis. So that's that first answer. Let P1 and P2 be these points respectively. Respectively means P1 is equal to that, and P2 is equal to that. What is the slope between these points? Well, slope looks like this. And we know it's delta y, so it's minus 6. So it's minus 6 minus 5, because that's the delta y. We're taking our y coordinate, so it's minus 6 minus 5 over 4 minus 2. And then simplifying the numerator, we get minus 11, and simplifying the denominator, we get 2. So slope is minus 11 over 2. Let's look at these points here. What is the slope between these ones? So we go 12. So m is equal to 12 minus 2 over 10 minus a negative 4. And it's the negative 4 like this. So we again simplify the numerator and denominator and pay close attention to detail of that negative and negative right here. That's very important. So it's 10 over a negative, and a negative is a positive. So you have 10 plus 4, so it's 14. And then you can divide the numerator by 2 and the denominator by 2, doing the same thing to both the numerator and denominator to get 5 over 7. So that would be our slope here. The function g of x has the point, so it has this point on it. What does g of p of x equal? Well, g of p of x is just p of y. It's the y coordinate of any point. The points, so these are all points that lie on a function f of x. What do these values equal? Well, f of 0 is equal to the y coordinate 5. F of 9 is just the y coordinate 10. F of minus 1 is negative 3. And f of 5 is 0. So there's that one. All right, so draw a plot with the points x0 and 0y on it. So let's just make a plot first off, xy, where x and y are both arbitrary real numbers, so they're just numbers. Also denote which point would be the x-intercept and which would be the y-intercept. So let's just make up a y-intercept. It crosses the line right there, and we know its coordinate kind of looks like that, right? And we know its x value right here would be 0. Okay, so we do know that. And we don't know the height, so let's just call the height y. Oh, and that's that point right there. So that's our y-intercept. What about our x-intercept? Let's make another point right there. It looks something like this. We don't know this value right here, but we do know this one, right? We know its height is 0. So we write 0 here. And then let's denote its value in the x direction, x. So we get x0. And this problem is done. That's that answer. Find x and y intercepts of this function right here. Okay, so this is an example of why that's kind of important. How we find a y-intercept, how I at least do it, is I draw a plot real quickly on my graph. And then I make up a y-intercept. I just denote it with a point. So I make up that point right there. And then I say, well, one of these must be 0. So in this case, it's the x value. So that's a 0. And then we plug in f of 0. So you get 0 squared minus 1. So we have f of 0 will be our y-intercept here, which we know it's really minus 1. So our y-intercept should really be down there, but we don't really care where it's positioned. We just want to know what it is. And then the x-intercept would be right here because it crosses through the x-axis. And our x-intercept is some coordinate right here. And we know its y-coordinate, right? We know that this must be 0 here. So we don't know its x value, so let's just call its x value x, just for simplicity. So we plug in x to f of x. I know it's kind of weird. We're plugging in x to f of x. So you get our y value. It spits out our y value. So f of x is equals to 0. We're wanting to solve for x here. Implies what? Well, f of x is equal to x squared minus 1. So x squared minus 1 is equal to 0. So then you add 1 to both sides, and then you get x is equal to 1, or x is equal to minus 1. So it's very important to remember that -1 case. So x could take on values 1 or -1. So we see there are actually two x-intercepts here. So we have 1, 0, and -1, 0 are our x-intercepts, and our y-intercept is 0, minus 1. All right, so we're given some function here. If f of 0 is equal to 10, then what is c? Well, let's just plug in f of 0 into our function. F of 0 is equal to 10 means what? F of 0 is equal to, we're plugging it in 0 everywhere we see x. So let's look at this term right here, okay? Every single one of these values, this is 0, this is 0, this is 0. And the reason for it, we're just multiplying numbers by 0 here. So this whole thing is really just 0. So you get c is equal to 10. I mean, so this whole thing is just really 0. So 0 plus c is equal to 10, so c is 10. That's the answer for that one. Let g of x equal to this function. If g of 0 is equal to 0, what is c? We do the same thing. G of 0 is equal to 0 means what? So we plug in g of 0 and we plug them into all these x's here. And again, the negative doesn't really matter because we know that this whole thing right here is 0, okay? This region right here is 0. So you get 0 plus c is equal to 0. So c must be 0 here as well. All right, so we're given this function here. What does f of 1 equal? So f of 1 would be 0. And the reason for it is we plug in our 1 for our x here. You get 1 minus 1, which is 0. And we know we don't care about these numbers out here. We know this one's 0 though. And we know 0 times any of these numbers will still be 0. So f of 1 is equal to 0. And the same thing with the minus 5.5 here. You have minus 5.5 plus 5.5, which is 0. And then you're just multiplying that through. So it's 0, spitting out the value 0 here. And f of 0 is equal to 0 because, you know, x is 0 here, right here. 2 times 0 is 0. And then we don't care about these values. These are some numbers. So you get 0 times these numbers. So that value also is 0. Let y of x equal to mx plus b. What is its y-intercept? Well, b is its y-intercept. So, but it should also kind of be apparent that our x-coordinate is 0 and our y-coordinate is 6. So our y-intercept is 0, 6. But let's just solve for b here. So we put y of 0 equal to m times 0 plus b. And then, so that gets just b is equal to 6. So our y-intercept is 0, 6. And that's from question 1. I think it's easier to look at it from right here, though. Let's expand this function right here. Okay, let's expand it. Well, h of x is equal to 2, very important on the parentheses right here, 2 times something right here. If we forget the parentheses right here, it'll turn out to be wrong. So it's 2 times something, and we're using the distributive property here. So you get x times x is x squared. So that's that term. X times a minus 3 is minus 3x. And then you have plus 5x and minus 15. And simplifying that, 5x minus 3x, we know that's 2x. So we get this equation here. And then you distribute the 2 through to all these terms. So you get 2x squared plus 4x minus 30. And that's it simplified. What is the equation of a line containing these points right here? Well, y is equal to mx plus b. Okay, so there's a few ways to do this. I'm going to show you. The first two aren't the best ways of doing it, but let's just go through it for good measure. Y is equal to mx plus b is the equation of a line. We want to figure out what m and b are to write our equations, so we leave those blank. And we know b is equal to minus 10 because that's the y-intercept. So that's minus 10. So y of x is equal to mx minus 10. And then you know, since y of 5 is equal to 6, because of that point right there, and you plug in y of 5 into here, so you get y of 5 is equal to m times 5 minus 10 for that left-hand side. You're going, and you know that 5m minus 10 is equal to 6. And from here, you can solve for m. So m is equal to 16 over 5. You plug that in there. And then you rewrite the equation of the line. So y of x is equal to 16x over 5 minus 10. And I wanted to point out how I didn't want you to write division symbols, but I think it's important you see it. The horizontal line is not as apparent. It's not as easy to use as the backslash line is not as easy to use as the horizontal line. Okay. It's easy to type in on your calculator, but it's not. You don't see it written in upper level math classes. Let's do this another way. Here, m, we know our slope is 6 minus 10, minus a negative 10. I said that wrong. I caught myself on that one. 6 minus a negative 10 for our numerator over 5 minus 0. So 5 minus 0, the change in x. Again, that backslash symbol it's not a classy notation in math. It's harder to use. You get 6 plus 10 is 16 over 5 is our slope. So y is equal to 16 over 5x minus 10. And we have to multiply left to right. So we can write it actually this way. It's not dividing 5x. It's going 16 divided by 5, and then it's multiplying it by x. And again, that notation is kind of sketchy. So this is the best way to write it. Look at how clear this way is. So y is equal to m. So 6 minus a negative 10 is our m value over 5 minus 0 is our m value. And we know by simplifying we get here x minus 10, which we know the minus 10 is here from our y-intercept. So much easier to do it this way. I really encourage you to do it this way. This is how you would write this problem out well. Okay, that's the best way of doing it. Fill in the blank. If two lines are parallel, they have the same slope. Parallel lines have same slope. Same slope means lines are parallel. I mean, technically different intercepts, but look at these lines right here. These lines look parallel. This line is g of x is equal to 2x. This one function right here is that just shifted up 1. So we see that these lines have the same slope. They're also parallel, okay? Parallel lines, same slope. Here we have two lines. They are parallel because they have the same, look at those values, same slope. They have the same slope and different y-intercepts. So, I mean, we don't really care about the y-intercepts. I mean, we do care about them, but the big idea is parallel lines, same slope. I'm driving that point home. So for this question, we have two tanks. Let's call it one tank A and B for brevity. So for short, see the picture below. We have tank A, tank B. Both tanks have a certain amount of liquid in them to start. So they have a certain amount of liquid in them to start. We're going to fill tank A and drain it simultaneously. Well, we are kind of denoting that in our picture here. When we fill and drain our tanks, we have two sensors that measure the height of fluid in feet. So we're determining the height as a function of time in seconds. These two functions of time are said to be the following. So these values are really our height values right here. And t is typically time, so that makes sense. So looking at the diagram below, what is tank A and which one is B? Explain how you know which one is which. So we have our question here. I just copied and pasted it real quick. Whenever you see something like this in math, this is kind of a trick. Mathematicians always do this. They always they align it in LaTeX like this real nice. That's the important stuff. That's the stuff we care about. So let's grab those functions right there. Those ones that are in the center. Which one is A and which one is B? So, well, this one must be A. And the reason we know it's A is because g of t has a positive slope here. So g of t is filling up. And this tank right here must be B because it's negative slope. So the height is it's decreasing. This one is going up, it's filling up. This one is decreasing, so it's negative slope. So that's one way of explaining it. The other way of saying it is that, and this is supposed to be at time t equals 0. Since g of 0 is equal to 2, we plug in t equals 0 there. So since g of 0 is equal to 2 and h of 0 is equal to 20, tank A must be g of t. And the reason for it is that we see that this height is way less than this height over here, which is, so this one must be 2 and this one must be 20. All right, so, and now this question says, record I know I have a spelling error. Sorry about that. Record all the times which both tanks have the same height. By each time, record the height at a specified time. So we want to know the times which, so let's see a demo right here. This is kind of cool. So we know G of t, its height is 2 feet right here, and this height is 20 feet when time t is equal to 0. So we're going to fill this up. This one's being filled up, this one's being drained, and we see here eventually that their heights become the same, right? And when their heights become the same, right here at this point, G of t and H of t are what? They're both 8, but we don't know that yet. That was kind of a demo. We know that these things are both equal. So what we do is we set G of t equal to H of t, and then we solve for whatever value t will be in hopes of finding t is equal to 8. So that's what we're trying to do here. Solve for t given G of t is equal to H of t. All right. Sorry about that. So solve for t given G of t is equal to H of t. All right, so, well, we set G of t equal to H of t, and by substitution, we get 3t plus 2, because that's G of t, is equal to minus 6t plus 20, because that's H of t. And then we subtract 2 on both sides, we get 18, and then we're bringing the 6t over here. We add 6t to both sides, so 9t is equal to 18. Divide both sides by 9, you get t is equal to 2. It therefore takes 2 seconds for the heights to be the same. So our time right here is 2 seconds for the height to be the same. But we want to know the height of the liquid here. So the height is just whatever our function is at that time. So G of 2 seconds equals 8. That spits out the height. So it's 8 feet. So at the time t is equal to 2 seconds, we get our value of our height equal to 8 feet. All right, for this one, it wants to find us a proof. We're going to find a common denominator here. The first step is to identify what the common denominator is, and it's always these values multiplied together. So we're going to have to multiply, so it's AB is the common denominator. So this value has to be multiplied by B right here, as well as the numerator. And this value has to be multiplied by A, as well as the numerator has to be multiplied by A. And we need the parentheses around the whole thing right here. We need the parentheses around the whole x plus 1 term, because you can't just multiply A times x. You have to do it the whole numerator right here. So that's the first step. And then the second step is to distribute the A in here. So we're distributing the A in here. So you get this. And now we have a common denominator, which means we can simplify, we can combine this line into one big old line. So you get this value right here, xb plus ax plus a for our numerator, and that proof is done. All right, now we see 3 lines are given below. We have 3 lines. What are the equations of them? Well, g of x, okay, so let's look at g of x right here. We see its run is 2, and we see its rise is 1, 2, 3. And we have to identify 2 points. Okay, before that, we identify 2 points which they're crossing the grid. Okay, so right there it's crossing the grid, and right there it's crossing the grid at those points. So g of x is equal to 3 over 2 is the slope right there, times x plus our y-intercept. What's our y-intercept? It's 0, 2. So it's 2. H of x, so this one has, its run is 1, and its rise is also 1, so it's 1 over 1. So but it's negative, so it's minus x. So it's really a negative 1 over here. So it's minus x. But we get rid of the 1 because it's more simply stated like this. So you get minus x plus 4. For the last one, you find the rise here, and you know the rise here is 1.5. You take that. For this one here, you find the your rise right here, which we know our rise is top minus bottom. So it's minus 3.5 minus a negative 5. You always make sure to have this number minus this number. So we have the double negative right here. So this is really your adding. So you see minus 3.5 plus 5, and that's 1.5. We can use our calculator for that. So you get that value right there, and then this is our delta y here. And we also know its run is 5. So its run is 5. So let's just write L of x is equal to 1.5 over 5. So it's the rise. So we just said that the rise is 1.5 here over our run, which is 5 here. But we have to make sure that there's a negative right here because this slope it's going down. So it's negative 1.5 over 5x. And we know its y-intercept is minus 3.5, so we have the minus 3.5 right there. And so we simplify to get to this equation right here. So this is just 1.5 divided by 5, and that's our answer.